Good afternoon, class. We are looking at Chapter 8, Further Application of Trigonometric Functions, 8.1, the Law of Sine. So using sine law, we want to solve SSA triangle, where A is 35 degrees and A and B are 8. Okay. So let's see what we do here. We are going to write the sine law, sine A over A, sine B over B. And A is 35 degrees. We are going to replace it. A lowercase a is 6. So the reason we use this one, because we have capital A and lowercase a, and we have lowercase b, we can easily find sine B. Let's plug in. So sine B, 6 times sine B, cross product, is 8 times sine 35. So sine B is 8 times sine 35, divided by number 6. And so at this point, you have to put it into a calculator with a bunch of decimals. We do that, it results in 0.7648. So if sine is equal to 0.7648, then B is sine inverse of this number. So B1 is sine inverse of 0.7648. To work it out with a calculator, it results in 49.9 degrees. Why are we calling it B1? Because as you know, sine is positive in the first and the second quadrant. And this acts as a reference arc. So what would be the second angle in the second quadrant? Subtract this from 180. You get 130.1 degrees. So that means those are the two angles. Would they work? Let's find out. Obviously, this works because the sum of these two is less than 180. You can figure out the rest. What about these two? If you add them up, you get 165.1, less than 180. This works as well, everybody. So there are two answers. If we were to do the drawing, this is 35 degrees. A, we're going to call it B1, B2, C, and lowercase a side is 6, and this is also 6. And B is 8, which means we have this entire triangle, or we have this little one, either one, okay? So we have either this one or the big guy. So if that is the case, the very first thing we're going to come up with is the third angle. Add these two, subtract it from 180. That's the first thing. A is 35, B1 is 49.9, add them up, subtract it from 180, it results in 95.1 degrees. That is one of those angles. Now, since we call this B sub 1, let's call the final side, B sub 1 is this one, okay? Is this angle, everybody, this angle, okay? Versus this angle, okay? So B sub 1, I mean, is 49.9, but B sub 2 is obtuse. This is obtuse. So we can write that if you want. So B sub 1, what was it? 49.9. And B sub 2 is the large one. Let me erase the book first. So this is 49.9. This is 130.1 degrees. And so now we're going to go back and say sine of, so we're going to use this. And now sine C over C, and we're going to call it C sub 1 because there are two that we come up with. And this C, okay, is the entire one. That means AB1, AB1, that's what it is. So what is C sub 1? The product of these two, 6 times sine 95.1 divided by sine 35. 6 times, so cross product. So let's do this. Is 2 times and divide by sine 35. You put it into a calculator and it results in 1042. Therefore, this distance of AB1 is 1042. Let's go to this one and say, okay, now we have 35 degrees. We have 130.1 degrees. What is the last angle? Okay. 180 minus the sum of the two. That means 180 minus 35 and minus 130.1. It gives you 14.9. So we are going to go back to this with this one. Sine of 35 over 6. Sine C over C. This one is sine of C sub 2, which is 14.9 degree by C sub 2. And by the way, this is C sub 2, AB2. And so we do that, and that means C sub 2 is the product of these two and product of these two. So 6 times sine of 14.9 divided by sine of 35. And it gives you 2.69. Let's put in all those values. So this is 2.69, this is 10.42, this is 130.1, this is 14.9, this is 49.9. As you can see, there are two outcomes. So it's possible to have two outcomes. Again, a quick recap. How do we end up with two outcomes? When you calculate the sine, it does give you two answers, one in the first, one in the second quadrant. As long as the sum of the given angle with those is less than 180, both of them work. So the sum of these two is less than 180, so this gives you one. The sum of these two is less than 180, this gives you a different one. And that's the bottom line. Now, let's look at side-side angle, where A is 2, lowercase c is 1, and capital C is 50 degrees. So obviously sine A over A, sine C over C because of what's given, right? Sine A over A, sine C over C. Again, because of what's given. So what is sine A? We have no idea. What is lowercase a is 2? What is sine C? Sine of 50 degrees. And what is C? It's 1. Which means sine A times 1 is 2 times sine 50. So sine A is 2 times sine 50. Now, if you put this into a calculator and multiply it by 2 gives you 1.53. Can sine be larger than 1? The answer is no. So there is no triangle because sine must be between -1 and 1, so this doesn't work. Okay, so if you were to draw that, here's what's going to happen, everybody. A is 2. C is 50, and lowercase is c is 1. So it never touches this if you were to graph it. So let me, this would have been A. Let's look at some applications. Solve applied problems. This is given, so let's do the reading. A surveyor takes two sightings of the peak of a mountain at a distance of 900 meters apart. So this is the peak. So we're going to do it right here. And then we go 900 meters back and we do it again. When we do the sighting here, this is 47 degrees. When we go back by 900 meters, it's 35 degrees. Okay. So one more time, a surveyor takes two sightings of the peak of a mountain at a distance of 900 meters apart on a direct line to the mountain. The observations are at angle of elevation of 47 and 35 degrees, respectively. If the transit that they're using is 2 meters high, so from here, what is the height of the mountain? So I hope you realize that the height of the mountain is h plus 2. So if you were to draw this, this is 35 degrees, this is 47 degrees, this is 900 meters. Okay. If we call this capital C, so this is lowercase c, this is lowercase a, and this is 47, this is 35, and this is h, the entire distance from the peak to the ground. So we know the transit is 2 meters high, so 2 meters and b. So what is the height equal to? B plus 2. So let's call this PDC. And the height is b plus 2. If we can find b, we are done. We just add 2, and that would become the height. Well, if you look at these two angles, they add up to 180. So C plus 47 is 180. This is a straight angle, everybody. So look at this. This is 180. So we can find C to be 180 minus 47, 180 minus 47, or 133 degrees. So let me erase my work. So C, this angle, this is 133 degrees. So this is 35 degrees. This is 133 degrees. If you look at this triangle, A, this is A, everybody. A, let's just put it up there so it becomes clear. So this is A, right? A, B, D, A, B, D. 35 plus C plus A is 180. If C is 133, plus 35, 168 degrees, subtract it from 180, and you get 12 degrees. So A is 12 degrees, everybody. If A is 12 degrees, then in this triangle, we can find all sides because one side and all angles are known. And what we are really interested in is to find this side. We want to find this side. Okay. Therefore, we can find this large one, we can find this small one, we can find all sides. So sine of 12 degrees over 900 is sine of 133 degrees over the large side, lowercase c, and cross product means this lowercase c is the product of these two divided by sine of 12. So we are finding this one. Putting it into a calculator results in 3,165.86 meters. So now that we have this, if we go to the big one, the triangle ABC, we know this angle is 35 degrees. So sine of that is B over C, and C, we found it to be 3,165.86 meters. So B is the product of these two. C, which is this number, times sine of 35 degrees. And we end up with 1,815.86 meters. So if we have the B, we have the height, all we have to do add 2. And when we add 2, again, this is an estimate. They probably tell you how many decimals. So if you go with a whole number, 5 becomes 6. With 2, we have 1,818 meters. Okay. All right, here's another application problem. Coast Guard Station Zulu, right here, is located 120 miles due west of Station X-Ray. So there are two stations, X-Ray and Zulu, and their distance is 120 miles. A ship at sea sends an SOS, save our ship call, that is received by each station. So there's a SOS call, both of them receive it. The call to Station Zulu indicates that the location of a ship is 40 degrees east of north, meaning the bearing is north 40 degrees east. So this is 40 degrees. And right away, if this is 40, then obviously this would be 90 minus 40 or 50. So we can figure this out. The call to X-ray indicates that the ship is 30 degrees west of north, meaning the bearing is north, 30 degrees west, north, 30 degrees west. So if that is 30 degrees, 90 minus 30 makes this one 60. So we have this one, we have this one. Obviously, we can figure this out. How far? So bearing is north 30 degrees west. How far is each station from the ship? Well, the very first thing we want to find is to find this angle 50 plus 60 subtracted from 180. And they add up to 110, subtracted from 180, you get 70 degrees. And so if we go with that, we have all angles, and we have one side, sine A over A, sine B over B, sine C over C. So sine 50 over A, sine 60 over B, sine 70 over C, or 120 miles. So this is 70 degrees, and this is the sine law. As you can see, A is missing, so is B. We can find it. So we're going to use this one with the first one to find A. A is the distance to X-ray, and then we're going to use this with this one to find the distance to Zulu. So for now, in other words, do this. Ignore that. So what is this? Cross product, right? Cross product means 120 times sine of 50 is A times sine of 70. Therefore, A is 120 sine 50 divided by sine 70. You put that into a calculator. So 120 times sine of 50 divided by sine of 70. Calculator will give you 97.82 miles, which means A has a distance of 97.82 miles, close to 98 miles. This is X-ray and it's done. But what about Zulu? Let me erase my work. Now put these two together to find B, cross product. Which means 120 times sine 60 is the same as B times sine 70. So B is 120 times sine 60 divided by sine 70. And so clearly, you put that into a calculator, and it results in 110.59 miles, close to 111 miles. So this distance is shorter than this distance. This distance is 97.82 miles. This distance is 110.59 miles. If a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? Obviously, we're going to go with A, the smaller of the two. And we know D is equal to RT, and T is the distance divided by R. What distance? The A distance, A over R. Why A? Because A is smaller, everybody. So we're going to use 97.82 and divide it by 200 miles to see how long it takes. 97.82 miles divided by 200 miles per hour, it gives us 0.489 hours. Okay. If you want to go with the minutes, remember 1 hour is 60 minutes. Then you multiply by 60, gives you 29.35 minutes. 29.35 minutes because we're going to use the smaller of the two. The highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado. Sidings to the same point at water level directly under the bridge are taken from each side of the 880 feet long bridge. As indicated in the figure, how high H is the bridge? Well, first let's call this side X. Second, let's do the drawing here, everybody. And this is 69.2 degrees. This is 65.5 degrees. This distance is 880 feet. We're going to call this X. We're going to call this ABC. Now, if we go to half of this triangle, one of them, doesn't matter which sides. For example, since we want X, we want to go to this side. We're going to call this D. So ACD. Right triangle, right? So in this triangle, sine of 69.2 is H over X. And therefore, H is the product of these two, which means if I can find X, if I can find this distance, I'm practically done. So we need to find X. So to find X, we're going to go to the big one. ABC, and we say, okay, this is 69.2 degrees, this is 65.5 degrees. This must be 180 minus the sum of the two. So C, this angle, must be 180 minus the sum of these two angles. We get 45.3 degrees. So this angle is 45.3. And clearly, we can use the sine law. Remember, we want X. So sine of 65.5 over X. And since we have 880 feet, we must use this one, sine of 45.3 over 880. And cross product indicates X times sine, 45.3 is 880 times sine of 65.5. So X is the product of these two divided by sine of 45.3. You have to put it into a calculator or replace the X exactly here, either way. So now that we have X, we put it in. And H becomes, the height becomes 1,126.57 times sine of 69.2 or 1,053.15, same units. This was 880 feet, so the units are the same in feet. The navigator of a ship at sea spots two lighthouses. Here's the ship, 1 and 2. That she knows to be 3 miles apart. So the distance between the two is 3 miles. We know that, along a straight seashore. She determines that the angle formed between two lines of sight of observation of the lighthouses and the line from the ship directly to shore are 15 and 35 degrees. In other words, this is 15 degrees, this is 35 degrees. How far is the ship from lighthouse P, from lighthouse Q? How far is the ship from the shore? In other words, this distance. So let's do the drawing and make sure everybody understands. So we have P, let's say this is R, this is Q, this is distance of 3 miles, this is 90-degree angle, this is 15, this is 35. So how far is the ship from the lighthouse P? We want PR. How far is it from the lighthouse Q? We want RQ. So we want to find those distances. So let's find all the angles. So how do we find all the angles? This is 90 degrees. So this is 90 minus 15. This is 90 minus 35. 90 minus 35 is 55. 90 minus 15 is 75. So again, I hope it's clear to everybody. So 90 minus 35, 90 minus 50. That's how you get those. And what is this angle? Or 15 and 35. They add up to 50 degrees. So this angle is the sum of these two. 15 plus 35. 15 plus 35. 50 degrees. So we got all the angles. And we have one side, so we can find all sides. Let me erase my work so it becomes clear. So we have this one to be 50 degrees. And so sine of this side, 50 degrees over PQ, which is 3, is sine of 55 over PR, which is missing. Cross product tells us that PR is 3 times sine 55 over sine 50. You have to put it into a calculator, and it gives you 3.21 miles. So this distance is 3.21 miles. Now we're going to use the same thing, sine of 50 over 3, because we have the angle and we have the side. Now the other one, sine of 75 over QR. So QR is the product of these two divided by sine of 50. You put that into a calculator, and you get 3.78 miles. And by the way, you expect it to be larger because the angle is larger here, right? Finally, how far is the ship from the shore? So we want this distance that is called D, everybody. This, we want this distance. So we have a choice of using the top or the bottom triangle because it's a right triangle. So if we use the top one, this is 75 degrees. We found the PR to be 3.21, and we're going to do that. Now, obviously, sine of 75 degrees is the opposite D over the hypotenuse 3.21. And therefore, D is the product of these two values, 3.21 times sine of 75. You put it into a calculator, you get 3.10 miles as the final answer. So a quick recap. We redraw this because this is 15 and 35, they add up to 50. Because this is 35 with this one, they add up to 90, so this is 55. Because this is 15, this must be 75. So you have all the angles, you can find all the sides. How do you find all the sides? One side, PQ, is given. So PR is 3.21, QR is 3.78, and then you use either the top or the bottom, one of those right triangles, in this case, the top one, and you can find sine is the opposite over the hypotenuse, and therefore this distance can be found to be 3.109.